Good afternoon, everyone. Welcome to the session for your course. And today we will be talking about limits, continuity, differentiation, and its application. I hope the screen is visible to you. Is the screen visible to you?
Yes, sir, please.
Okay, fine. Now, as I said, I will be talking about limit and continuity. The question arises what is actually meant by limit? Limit basically, as far as mathematics part is concerned, it says here that it is approaching. It's not that, but it is approaching to that value. We will be using the word LIM tends to with an arrow mark. I will show you throughout this limit, continuity, and a part of differentiation. The idea behind limit is to analyze the value that the function is approaching when its input approaches a specific value. We can see this graph. This graph, as far as the graph is concerned, it is marked by a green line. Now we have taken up a value on it. The value says that it is approaching A and we are getting a value of L. Similarly, what is going to happen now? As it may be seen that when x approaches the value A on the x-axis, the function approaches L on the y-axis. Now let us pay attention to the whole of the point AL that is marked by zero line. I'm talking about this point. This point gives the form of a small circle. Around that area, we don't necessarily know the value of the function f at x is equal to a. This is, we cannot work out the exact value of the function, but we can say that, or we can see that what it should be as we get closer and closer. Such a situation is expressed as limit. How do we speak? How do we spell out? Limit x tends to a, function of x, the value is a. This is what the term we will be using throughout this limits and derivatives. Now, we take up this function fx is equal to x square minus 1 upon x minus 1. We will try to solve it out. We will simplify the numerator. That is in the form of a square minus b square, which is equal to x minus 1 into x plus 1. That is the secondary part. Now, as soon as we apply the value of x is equal to 1 in this function, fx, so that will be in the form of 0 by 0, which doesn't mean any, or which doesn't solve our purpose. Now what we will see and we will do, if we approximately change the value, we say that it is approaching 1, but it is not exactly 1. What will happen in that case? We can put up another values of x, but it should be less than 1. And we will say that it is approaching 1. We had used the word approaching. Now, as soon as I put 1.5 over here, the value comes out to be 1.5. I kept 1.9, the value changes from 1.9. I just increase the decimal position of 0.99. It became 1.99. I took three values, three values after a decimal. It became 0.99, so it became 1.99. As soon as you say I'm increasing it, its value is approaching 1.99. Initially, you are seeing that it is 0, but how it is coming 1.99? Now, I will show you how it will come 1.99. I will just break this x square minus 1 to x minus 1 into x plus 1. From this x minus 1, the numerator x minus 1 will get cancelled. You will be left with limit x tends to 1, x plus 1. Now I will put up the value. I will get 2, mathematically 2. It's not 0 by 0, but it is exactly 2. This is what is meant by this, that it is approaching is not equal to 1. Calculatively, in the last part, we will substitute the value of x is equal to 1 in the function. Now we will be talking about continuous function. As the English meaning of continuous means in a line, in a rhythm, it's not breaking anyway. You can see this graph. We don't see any break in this graph. If we see any break in the graph, that is not. A continuous function indicates that small changes in the point of the function would result in small changes in its output. Now, what does that mean? Let it be any function. If I am putting up a value, I'm getting this point. I'm just increasing the value, I'm getting this point. As soon as I'm going on increasing the value, so I will be getting these points. At a particular point, I will get 0. Then it will start moving like this, it will come again to this. And in further to that values, it will be continuous, it won't be breaking. That means if a graph does not break, it is a continuous function. Now comes the limit. Symbolically, as I told you, it is written as, now I've changed that notification. Now here it is limit x tends to c, fx is equal to L. So now actually what does that mean? Above equation implies that as x approaches c, the limit of fx equals to L. Here x approximately equals to c, that is x can be less than c or greater than c, but x should not be equal to c. To find out the limit, we need to work with the value of the function for two different values. X. One for greater than c, that will be right hand limit. And another one, x less than c, that will be left hand limit. And we will verify that both these are equal or not. Now mathematically how it is written. The limit of a function will exist if and only if both left hand limit and right hand limits are equal. Now how we will show it? You can see to it, limit x tends to c plus, that means on the right side of c. For the value you will get limit as your answer as L. And for limit x tends to c negative, that means on the left side of c, you will again get the same value L. Which means, mathematically, that limit x tends to c, fx is equal to L. That means on solving it, your answer will be L. Now, we will see how it is approaching and what does this mean. You can see we have to find out the limit of x square when x tends to 2. Now what we will do? We will take up a value which is less than 2. And it will be almost to 2. As in the box you can see that value starts from 1. Straight away put this value 1 in this function. 1 square is 1. 1.4 square is 1.96. 1.7 square is 2.89. 1.8 square is 3.24. You can see that it is increasing. From 1.99 it is 3.96. And for 1.995 it is 3.98. And for 1.999 it is 3.99. Almost 4. Now we will take a value which is greater than 2. Greater than 2 is 3. 3 becomes 9. 2.6, 2.4, 2.2, 2.1, 2.01, 2.005, 2.001. As you can see that it is reducing. It is reducing. The value at 2.001 is 4.004 and at value 1.99 is 3.996. That means these two values are almost equal. We can say that for limit x tends to 2 plus x square, value is 4, and for limit x tends to 2 negative, value is x square, for is 4. That means that limit x tends to 2 x square is 4. This is what actually limit calculation is all about. Now we have these two, this problem. X squared, this is what basically the problem was given to us. Limit x square, x tends to 1, x square minus 1 upon x minus 1. First of all, what we have to do, we have to check it. That straight away putting up the value of 1 into it, what we are getting. Straight away, if we put up the value of x tends to 1 in this, that means x equal to 1, we are going to get 0. That is of no use. Now what we will do? We will solve it. We will break it. So we get x minus 1 into x plus 1 because it is in the form of x square minus 1 square. And x square minus a square is equal to x into x minus 1 into x plus 1. So we have split it. This x minus 1 and this x minus 1 will get cancelled. We will be left with limit x tends to 1 x plus 2. Now put up the value. This will become 1 plus 1, 2. This is actually what we will be following. Now we will be talking about some properties of limits. I hope every one of you is having pen and paper with you because it will be better if you write something which is new to you or something what you have studied but you cannot understand it. And if during this period, if you have any doubt, so straight away ask me. Any question?
And thank you, sir. You can proceed from my side.
Okay. Now, what are the properties of limits? Because if C be any constant and limit x tends to a fx, then the following are true. Now see to it. Limit of a constant is constant. It doesn't make any difference because it does not consist of any term of x will be k, which is a constant. Limit x tends to a, k fx. Now we will take k out and we will apply the limit in the function fx. Now if we have two functions in the form of sum or difference, mathematically limit will be applied individually to both of them. That means the question was limit x tends to a within bracket fx plus minus gx. Bracket close. What we will be doing? We will be applying limit individually. Limit x tends to a fx plus minus limit x tends to a gx. Similarly, what will happen if they are in the form of product form? The limit will be applied individually to the first function into the second function. Now, if they are in the division form, again the same thing will have to take place. Limit will be applicable in the numerator as well as denominator. But we have to remember one thing, that denominator should not be equal to 0. If denominator becomes 0, if the denominator is 0, that the question is meaningless. Now these are some of the standard results of the limits. If limit x tends to a, xn minus an upon x minus a is equal to n a raised to the power n minus 1. Limit x tends to 0, 1 plus x raised to the power of 1 plus x, that is equal to e. If the third property, limit x tends to 0, a raised to the power x minus 1 upon x is equal to log base e a. Limit x tends to 0, ex minus 1 upon x equal to 1. Limit x tends to 0, log 1 plus x upon x is equal to 1. These are the standard limits. You have to remember it because it will be easier for you to solve the problem. Now we will see to some of the problems. Your first problem is limit x tends to 2 to 9. We don't have any term related to x, so its answer will be 9. Now second one is limit x tends to 2, 3x square. Simply replace, or there is two options, take 3 common, 3 out. You can write it in this way. 3 will be written in front of limit x tends to 2x square. Apply x is equal to 2. You will get 3 into 2 raised to the power 2. That is 4. 3 into 4 is 12. Now, limit x tends to 2, 5x square plus 3x plus 7. You can apply it directly also. Replace x by 2. So it will become 5 into 4 plus 3 into 2 plus 7. That will become 5 into 4 is 20, 20 plus 6 is 26, 26 plus 7 is 33. Now the fourth one is, you can see that it is in the form of product. Two functions are in the form of product. So as soon as you will directly apply limit x tends to 1, the first bracket will become 5 and the second bracket will become minus 1. Now second bracket will become 1. 5 into 1 will be 5. In your next problem, it is the question is in the form of division. So what we will be applying? We will be applying straight away. So we will be replacing x by 1. That will become 2 plus 1, 3. 3 minus 3 is 0 upon 1 plus 9, that is 10. So 0 by 10 will be the answer, and which will be equal to 0. Is that clear to you?
Yes, sir.
Now, we will move to method of factorization. As I said, we have to see one thing, that is, it should not be in the form of 0 by 0. So for that, we have already done it, that we have to factorize the numerator, or we have to eliminate the 0 by 0 form. Now, what the theory says, if fx and gx are two functions, thus that limit x tends to a fx is equal to limit x tends to a gx, which is equal to 0. And we have to find this limit x tends to a fx upon gx. Then we obtain a 0 by 0 form, that is meaningless. So with that case, this 0 by 0 form is called an intermediate form. Other intermediate form will be plus minus infinity upon plus minus infinity. In such conditions, we have to apply the method of factorization. Now, is the screen visible to you?
From my side, oh, yes, sir.
Okay. Limit x tends to 5, x squared minus 3x minus 10 upon x squared minus 6x plus 5. This is the problem given to you. First of all, what we have to do? We have to check it out, its form. So what we will do? We will just place x equal to 5 in numerator as well as denominator. So it will be 25 minus 15 minus 10. So that will be 25 minus 25, 0. And in the denominator, what is coming? 25 minus 30 plus 5, again 0. It is in the form of 0 by 0, which is not acceptable. What we will do? We will see what is the nature of the function in numerator as well as in denominator. Both the functions are quadratic in nature. As these are quadratic in nature, so we will try to break up the middle term. Now the question arises how the middle term will be broken. So I have not written that method, but I am just telling you how it has been done. I hope you might be knowing it or you might recall it when I will be telling what I've done and how it is done. I have taken the coefficient of x squared, that is 1, and the constant term without x, that is 10. So 10 into 1 is 10. Now I will split. That means I will factorize 10 in such a form that I get by adding two numbers as sum of 3 or subtracting two numbers to get 3. What I will be doing? I cannot take 10 into 1. I will be taking 5 into 2. As I will be subtracting 2 from 5, I will get 3. So I will write it x squared minus 5x plus 2x minus 10. And similarly, I will be doing following the same method in denominator. Coefficient of x square is 1 and the constant term is 5. I will be multiplying 1 by 5. I will get 5. I have to factorize it to get 6. So see, simplest method is 5 plus 1. Since I have to get minus 6, so I will be splitting that minus x minus 5 x. Then only I will be getting 6. I will be solving it. So your numerator will be in the form of x plus 2 into x minus 5. And your denominator will be in the form of x minus 1, x minus 5. X minus 5 from numerator and denominator will get cancelled. You will be left with limit x tends to 5, x plus 2 divided by x minus 1. Now straight away put up the value x is equal to 5 in numerator as well as in denominator. You will get 7 by 4. Now you have seen it. The actual problem was in the form of 0 by 0. And after factorizing it, you have reduced that problem to 7 by 4. I hope I will just rejoin it because I think the video has freezed. Now we will see to another problem. this is limit x tends to 0 under root 1 plus x minus under root 1 minus x upon x. Straight away put up the value of x equal to 0. When you are putting x equal to 0, it becomes under root 1 minus under root upon 0. That is 1 minus 1 upon 0. 0 by 0 is here. The problem is that we have again got 0. We will reduce it or we will eliminate this problem. We will straight away rationalize with the numerator because we have to eliminate those parts where we have unders. So we will be rationalizing it with an opposite sign of this. So that will be under root 1 plus x minus under root 1 minus x upon x into under root 1 plus x plus under root 1 minus x upon under root 1 plus x plus under root 1 minus x. Mathematically, this is not going to affect anything. We will be applying a minus b into a plus b. So roots will be eliminated. You will be left with 1 plus x minus 1 plus x. Remove this. You will be left with 2x upon x. Now remove this x from this x. Now this is what you are left with. Now apply x is equal to 0. You will get 2 by 2, which is 1. You can see here in this part it was 0 by 0. Now it is 1. So this is what we have to keep in mind while solving the problems of limits. That it should not be in the form of 0 by 0. If anywhere you find that change the form either by rationalizing or by factorizing. Now, another problem here, the limit is not to a natural number, it is to infinity. So here the problem is limit x tends to infinity 2x square plus 5x plus 1 upon 3x square minus 2x plus 4. If you are going to apply this, what is the problem will look like? It is not to infinity, but it is approaching infinity. So when mathematically if we say that x is approaching infinity, the numerator and denominator both will reach to infinity. That means it will be in the form of infinity by infinity. What to do in that case? Straight away, in the numerator or in the denominator, see the maximum value of the power. In numerator, maximum power is 2, and in denominator, power is 3. So straight away, without thinking of anything, you straight away divide numerator and denominator by x cube. As soon as you will be gonna keep one thing in mind. Mathematically, it is said dividing numerator and denominator by x cube. But actually, it is performed that each element of the numerator will be divided by x cube. Remember that thing, each element of numerator and denominator will be divided by x cube. When you will be dividing 2x square by x cube, you will be left with 2 by x. When you will be dividing 5x by x cube, you will be left with 5x square. And when you will be dividing 1 by x cube, it will be 1 by x cube. That is for the numerator. As for the denominator, it will be 3 minus 2 by x square plus 4 by x cube. Now you have to apply the limit. Now what will happen? This part will be 0, this will be 0, this will be 0. The numerator will be 0. And in denominator, you don't have x in this. It will be 0 by 3. And 0 by 3 is, you can see, from infinity to infinity, infinity by infinity, we have reduced the problem to 0. Is that clear?
For now, yes, sir.
Okay. Now we move to continuity. As I said, continuity means continuous. In that case, simply you have to remember that left hand limit should be equal to left hand limit, right hand limit, and should be equal to the value of the limit. Now, mathematically, what does that mean? A function f is said to be continuous at x is equal to c if the function is defined at x is equal to c and limit x tends to c, fx is equal to fc. And we have to keep one thing in mind, that limit x tends to c negative, fx should be equal to fc, and that should be equal to limit x tends to c plus fx. Again, it should be fc. If all these three values are equal, that means a function is continuous. If fx is continuous for every value of x in its domain, it is said to be continuous throughout the interval. And if a function which is not continuous at a point is said to have a discontinuity at that point, a function f is continuous over an interval ab. And if it is continuous at every point within the interval, that means between a and b. What are the properties of continuity? Fx is equal to a constant, is constant for all real numbers x. Fx is equal to x raised to the power n, where n is a natural number, is continuous for all real numbers x. Polynomial functions are continuous for all real numbers. And if the two functions are in plus minus form, that means either in addition or in subtraction, they are continuous, then their sum and differences of two continuous functions are also continuous. If they are in the form of product, that means fx into gx, if the two functions are continuous, then their product is also continuous. And similarly, if they are in the form of division, but for division you have to keep one thing in mind. Your denominator should not be 0. That means gx should not be 0. In that case, the two functions will be continuous. Now we will see a problem. This is a problem fx equal to. See how it is written. It is written in three steps. Fx is equal to x plus 1. If minus 1 is less than x, less than equal to x, and less than 0. X, if 0 is less than equal to x, less than equal to 1. And 2 minus x, if 1 is less than equal to x, less than equal to 2. Now what we are supposed to do? We have to show that it is discontinuous at x is equal to 0, but it is continuous at x is equal to 1. This is the point what you have to refer it. In a problem, I am showing you discontinuity and continuity. Now straight away, he said, the question says that the function is discontinuous at x is equal to 0. Okay, we will find out what will happen to the function when x is equal to 0. Go back to the problem. Find out where the function is. Here is the function between 0 and 1. Correct? So your fx will be x. Straight away put f0, it will become 0. Limit for checking up of the continuity. You have to check its value at limit x tends to 0 negative as well as at x is equal to 0 positive. When you are talking about x 0 negative, here this is the function. 0 negative is this function. X plus 1, apply the limit, you will get 1. And when you are applying for x 0 positive means fx, that will be 0. You can straight away say that x tends to 0 plus is not equal to limit x tends to 0 minus, because these three values have to be equal. For a function to be continuous, left hand limit should be equal to right hand limit and should be equal to the value of the limit. Your value of the limit is 0, your right hand limit is 0, but your left hand limit is 1. That means it is discontinuous at x is equal to 0. But now we move to show that it is continuous at x is equal to 1. In that case, what we will be doing? Function will remain the same. f1, fx, f1 will be equal to 1. Now, when we talk about the terms of x, 1 plus is which part? Greater than 1, less than 2. This part we will pick this function, 2 minus x. We will apply the limit 1. So it will be 2 minus 1 equal to 1. fx, 1 negative. Negative is this part only. That means fx, 1 negative, so we will be applying the limit, so it will be 1. This is 1, this is 1. Now what is the value of the limit? f1 is 1. All these three values are equal. When all these three values are equal, we can straight away say that the function is continuous at x is equal to 1. Is that clear? In a problem, we have shown that the function is discontinuous at x is equal to 0, but it is continuous at x is equal to 1. Is that clear?
No, sir. Can you elaborate?
No, sir. What you have not understood? That is the thing.
In here we have, for example, fx is equal to in 3 coin x plus 1, x minus 2 minus x. In the interval of minus 1 equal or less than x and is less than 0.
Correct.
In here we don't have 1.
Here we don't have 1, but we have said we are talking about, we are checking the continuity of a function. It is basically, the function is in form of 3 states. And under 3 states, 3 different conditions are provided to you. When we are, I'm telling you once again what you want to know. The function has been given to you in 3 forms with 3 different conditions. And now they are asking you to check its continuity. Like what is visible to you in the slide. Just have a look at this part. First line. It is minus 1 and 0. That means on the left side. Correct?
Yes, sir.
The function, I will take in the, not in the mathematical term, but I will explain you in the other term. Now you can see minus 1 to 0. That means no doubt it will be on the left hand side.
Yes.
The function is x plus 1. Okay?
Yeah.
Here you can see that it is 0 to 1. Between 0 to 1.
Yes.
That the function is fx. That means your basic function is this.
Yeah, x.
X. fx is equal to x.
Yes.
And in the third line, you can see that it is 1 less than equal to x less than equal to 2. That means it is out from the right hand side of the 1.
Yes.
Three parts are there. Now apply the limit x equal to 1. Okay.
Yeah.
Your basic function is fx, which is equal to x. So that will be 1.
Yes.
Now, if we talk in terms of x plus 1, you said this is the function for x plus 1, 2 minus x. Put up the value of x equal to 1 into this function. You will
Equal
get
to 1.
you will get plus 1.
Yes.
Now, for left hand limit, what will you do?
Since left hand and right hand equal to 1, it will continues.
All left hand limit is equal to right hand limit is equal to 1, value
Yeah.
of the limit. Under that condition, it is continuous.
Yes, thank you, sir.
Okay.
I got it.
Anyone else has any problem? Now check the find the point of discontinuity of this function. 2x square plus 6x minus 5 upon 12x square plus x minus 20. You have to check the point of discontinuity. Okay. The given function will be discontinuous at a point where the denominator will be equal to 0. If denominator is equal to 0, we have to find that point where the denominator will be 0. So straight away what we will be doing? We will be putting up 12x square plus x minus 20 equal to 0. Multiply 12 by 20, you will get 240. Now split 240 in such a form that if you add or subtract, you get plus 1. So straight away you can see that plus x has been split in the form of 16x minus 15x. So your second line is 12x squared plus 16x minus 15x minus 20 equal to 0. Take 4x common. The first bracket will be 3x plus 4. Now take minus 5 common. The second bracket will be the same of the earlier one, which is 3x plus 4 equal to 0. Take 3x plus 4 common, and then the another bracket you will get 4x minus 5. You will get the value of x equal to 5 by 4 and minus 4 by 3. That means these are the points of discontinuity. For a function to be discontinuous, your denominator has to be 0. Is that clear? Now, a function is defined as y is equal to fx equal to x squared minus x minus 12 upon x minus 4. You have to evaluate the limit of y when x is 4. That means x is approaching 4. And number 2, is the function continuous at x is equal to 4? Two things have to be evaluated. So first of all, we will apply the limit x tends to 4. So it will be written as limit x tends to 4 of y. We will be replacing that y by fx. And in the third step, we will be replacing fx by x squared minus x minus 12 by x minus 4. When you are applying limit, you are getting the value of 0 y. Because In denominator, you have 4 minus 4, that is 0. And in the numerator, that will be 16 minus 16, again 0. It is in the form of 0 by 0. You have to factorize the numerator. You will be factorizing the numerator. After factorizing, you will get x minus 4 into x plus 3. X minus 4 from the numerator and x minus 4 from the denominator will get cancelled. You will be left with x plus 3. Now apply the limit. X tends to 4 to x plus 3. It will become 4 plus 3, that is 7. Okay. Now, we have to see that. The second part is the function continuous at x is equal to 4? As soon as you will be putting x is equal to 4 to the problem, you will get 0 by 0 4, because denominator will become 4 minus 4, that is 3. The function y is not defined at x is equal to 4. Therefore, the function is not continuous at x is equal to 4. Is that clear now?
Yes, sir, this is clear for me, but I don't know.
Anyone else? Two more learners are there. I just want their feedback. What are they doing and what they have
I
understood?
think I think they have some problem with the lecture, and they are not uh, have a pre-idea about the university lecturer and how they should perceive or understand this section. And the lecture is going very fast.
Lecture is that is what I'm asking you again and again. Where the problem is, unless and until it will be told to me, that then only I will be in a position to understand.
Yes, I think we will do it in later and asking them to do from their side.
This is what uh, as far as this method is concerned. The method is very simple, and it is we have all done it in your 10 plus 2 level or intermediate level. That is of that part only.
Yes, sir. I think if you share this presentation with us and before the lecture is started, it will be very good
No,
because
no.
we
So
reviewing this.
you have to go through to with your study material.
Okay,
Because
sir.
yeah, but I'm not taking any another example from anywhere. It's all from your study material because you will be going through it. I'm just telling you that the methods and the shortcuts, how it can be made easier for you.
Yes, I do understand.
This is what I'm telling you.
Thank you so much, sir.
Now, a problem related to in the form of treatment. And now we have to convert that statement problem into a limit problem, and then we have to calculate the. Now, see how the statement is converted into a mathematical relation. An electric company charges from its customer the following amount of service: rupees 5 for first 20 kilowatts hour or less. Listen to it very carefully how this has been, what, how your electric company are charged, how they normally charge. They are exactly charging is not something different, but how they normally charge. Rupees 5 for first 20 kilowatts or less. That means if you use 20 kilowatts hour or less than in their billing period, you will be charged a fixed amount of rupees 5. Correct? Now, second line is 25 paisa per kilowatt hour for next 80 units. 80 kilowatt hours and 10 paisa per kilowatt for any hour above 100 kilowatt hour. If X is the number of kilowatt hours, express the cost as a function of X. Also test the continuity of C at X is equal to 20 and X is equal to 100. Now it becomes very difficult to understand how this problem can be resolved. Here we can see that three conditions are given to us. First condition is units are less than 20 kilo. Correct? Second condition is that if it is between 20 and next 80 kilowatt hours. Actually, kilowatt hours is units. So we can see that for next 20, this is 25 paisa per kilowatt hour for next 80 kilowatt hours. Now try to understand what I need to say here. What is the mathematical per component, how it is calculated. Suppose how this second condition is formulated. That they are saying that at second condition your consumption is 100 units. That means if your consumption is of 100 units, so you will be paying the amount of from 20 to 80. Till 20 you have already paid rupees 5. You have already paid this rupees 5 till 20. I'm talking about this component which is between 20, more than 20 and less than 100. From now the question is from where this 100 came. It is 20 plus 80 units next. This is the next 80 units. It will be what? 25 paisa. Your unit is 25 paisa means 25 by 100. That is 1 by 4 for what? X minus 20. This is the second part. Now in the third part what it says, and 10 paisa per kilowatt for any hours above 100 hours. Now what happens? You have already utilized this part, 10 paisa 1 by 10 into number of units minus 100, because this is the condition for X greater than 100. That means your billing has been done in three parts. First part is up to 20 kilowatt hours, that is 20 units. Second one is from 20 to next 100, next 80, so that is 20 to 100. And the third one is anything above. So that is very much, it should be into your mind that if we are talking about 20 units and less, it will be rupees 5. If it is more than 20 but less than 100, it will be 5 plus number of units more than 20. And in the third case, it will be 100 units plus 1 by 10 of any unit which is more than 100. It will be written in this form. That means your cost function is now defined by three functions independently working under three different conditions. Now what the question says, if X is the number of kilowatt hours, express the total cost as a function of X. This part has been done. Now we have to test the continuity of C at X when X is 20 and X is 100. For continuity check, what we have to do? Can any one of you tell me for continuity what we are supposed to do?
We should check the right hand and left hand are equal or not. If they are equal and the x point 20, x equal to 20, this function is continuity.
Absolutely. Because we have to check for x is equal to 20 and x is equal to 100. That means we have to check for the left hand limit, right hand limit, and value of the limit. For continuity, you have to do both the three things. I will be doing first part. Now this is the function. Okay, correct? This is the function.
Yes, sir.
X is equal to 20. Your C will be 20. For C20, your cost will be 5 because till 20, it is a fixed cost of 5.
This constant is equal to 5.
Now for the left hand limit, what I will be doing? I will be taking x tends to 20 negative. 20 negative comes where?
20 negative comes in the first part.
It will be 5. Correct?
5. Yes.
For right hand limit, that is 20 plus.
The second function is equal to 5 plus 1 by 4 x minus 20.
When you will be applying limit, what will happen?
This become 5.
You
It's
will be you will be getting 5 only.
yes.
You will be getting 5 only. And
Yes.
for the limit x 20,
Yes,
your
sir.
value is 5. That means in all the three cases, your value is 5. That means the function Cx is continuous at x is equal to 20. Is that correct?
Yes, sir. I got it, sir.
Got it? Okay.
Yes. Thank you, sir.
Now we will be moving further. Now we will be moving to the next concept, which is next to this part, that is differentiation, or what we call it as differential equation. After limits and continuity, this component comes.
Dear sir, your representation is not visible to us.
It will be made visible to you, sir. Just a minute. I hope now it is visible.
Yeah, it's visible.
Now we will move to differential calculus, which has differentiation, application of differentiation, and application of differentials. You have three units in it. Today I will be talking about differentiation. Actually, what differentiation means? See, apart from mathematics, we have a big thing. From a big thing, we would like to study the smaller thing. There is a difference. Mathematically, we are doing the same thing, but from a big piece of thing, we are just trying to study a small piece. That is differentiation. This, as far as this differentiation is mathematically is concerned, it has different rules, methods. We have standard derivatives. We will be talking about implicit functions. We will be talking about using of logarithm and parametric functions. Now the thing is that what does this derivative is? Derivative in calculus is the rate of change of a quantity y with respect to another quantity x. It is also termed the differential coefficient of y. with respect to x. Differentiation is the process of finding derivative of a function. Whenever we will be talking about differentiation, that means we have to find a derivative. Now the thing is that a derivative is the limit of the ratio of the small increment in one variable of the function corresponding to a small increment in the argument, that is the other variable, as the later tends to zero. If you can remember just half an hour earlier, I was telling you that the limit says that it is approaching zero or approaching C or approaching A, but it is not actually A, C, or D. So here what you are saying that for an incremental change in one element, there is simultaneously an incremental change in the other. Now see, what are the various functions which are used in derivatives? Simply, it will be in the form of a function y equal to something in x. When you will be differentiating it, so you will be writing dy by dx. If the same function is given to you in the form of fx, in that case you will be writing f dash x or d by dx of fx. All three things are one in the same. But we have to keep an eye in what condition, in what terminology the question has been asked. Now, what does the definition of derivative say? Simply is that dy by dx is equal to limit delta x tends to 0, delta y upon delta x. Delta x means small change in the value of x. So similarly, we will be having small change in the value of y also. So that is why it is written as limit delta x tends to 0, delta y upon delta x, which is the derivative of the function. Now, another mathematical relation, why do we find derivative? We have to find the slope. Slope means the inclination. Now, if we have 2 points, we have these 2 points x1, x2, x1, y1, and x2, y2. The slope, that is dy by dx, is equal to slope is equal to y2 minus y1 upon x2 minus x1. These points will be numerical number. So we will be simply subtracting the y term, y coordinates, and then we will be subtracting x coordinates and we will be dividing. Y coordinates will be in the numerator and x coordinates will be in the denominator. Now, what are the different rules for computing the derivatives? Now, see how much think has to be learned. We can start from anywhere, but it will be better if we start from this part and we will go this way. That is in clockwise direction. First of all, there is chain rule. Another thing is quotient rule. Third thing is product rule. Then comes the rule of sum and differences. Then comes linear function rule, power function rule, and constant function rule. So these are the different methods by which derivative of the function is evaluated. Now, first method is differentiation by first principle. I will show you how it is performed and what does this actually mean. It is applicable to all. Not that it is applicable to this part only, it is applicable to all. What does the definition say? The function y is equal to fx is said to be differentiable at x is equal to c. If you can see that if means limit s tends to 0 fc plus f minus fc upon x exists, and the limit is called the derivative of the function fx at x is equal to c, and it is denoted by f dash x or yx or dy by dx. Now we will be applying this first principle rule to this problem. The problem is y is equal to x squared. In that case, as it was told to you that we will be adding a small increment on x as well as to the y. So straight away you can see that the small increment is denoted by delta x and delta y. So on the y side we will be adding delta y, and on the x side we will be adding delta x. Now see, your question was y is equal to x square. So that y has been changed to y plus delta y is equal to, the function was x square. So on x you are adding delta x. So it will be become x plus delta x whole square. Now open it. Numerator left side will remain the same. Right hand side will be a plus b whole square is a square plus 2ab plus b square. Right away it will become x square plus 2x delta x plus delta x whole square. Okay, now what is being done? What I have done, I have replaced this y by x square. As soon as I replaced it, this x square and this x square got cancelled. Okay. Now you are left with delta y equal to delta x 2x delta x plus delta x whole square. Now divide both sides by delta x. As soon as you will be dividing both sides by delta x, it will become delta y by delta x is equal to 2x plus delta x. Now apply the limit. Delta x tends to, as soon as you will be applying limit delta x tends to 0 on both sides, here as well as here. This delta y upon delta x will become dy by dx. Okay. And when you will be applying limit delta x tends to 0, to this part, you will be only left with 2x. Now the question arises how? Because there is no term. You will be dividing by this, so this will be delta x tends to 0, this will be 0, you will be left with 2x. That means we can say that derivative of y is derivative of y is equal to x square is 2x. You can see to it how the first principle is applied to find the derivative of y is equal to x square. I'm just repeating it once again. We are adding small increments on y as well as on x. So y will become y plus delta y and x will become x plus delta x. Now you have to apply everything as usual, because you have to apply initially a plus b whole square. That will be, in this case, it will be x square plus 2x delta x plus delta x square. On the left hand side, you can see that it is with y plus delta y. So we can replace y by x square. When we will be replacing y by x square, so x square from the left side and x square from the right hand side will get cancelled. Now you are having this. Divide by both sides by delta x. When you will be dividing delta y by delta x, you will get this. This delta x will be reduced, and this delta x will become delta x. Now apply the limit delta x tends to 0. As soon as the limit is applied over here, it will become dy by dx. Now as far as this part is concerned, so this will be finished off and you will be left with 2x. This is how first principle of is applied. Now we will see to a problem which is quadratic in nature. So as soon as per the definition of this system, if we have to find the derivative, what we will do, we will replace x by x plus delta x. And as far as your fx is concerned, it will be in terms of x only, and it will be f dash x. Now, we apply limit delta x tends to 0. This is the basic formula of the derivatives. This has been shown to you over here. This is what is being performed. Now see, delta x tends to 0, fx plus delta x minus fx upon delta x. Straight away, start applying the value. This will become x plus delta x whole square minus 3 times of x plus delta x plus 5 minus delta x, but this is x square minus 3x plus 5. Open it. What it looks like: x square plus 2x delta x plus delta x whole square minus 3x square plus x square minus 3x minus 3 delta x plus 5 minus x square plus 3x plus minus 5 divided by delta x. What we will do, we will be taking delta x common. After taking or adding and submitting all these values, see to it. This x square and this x square will be removed. This is, we will be left with this, 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 this one, this and this. Here it comes in this one. You will be having 2x into delta x plus delta x whole square minus 3 delta x. What we, upon delta x. So straight away we can see that in the numerator, all the three terms have delta x in common. Straight away take delta x common. As soon as you take delta x common, you are left with 2x plus delta x minus 3. However, it will be dash x equal to 2x minus 3 because all other terms will be t. We can straight away say that when we are finding a derivative of a function, we are just finding out a slope of the tangent line. Is that clear?
For
This is
now,
the
yes, sir.
This is the application of first principle of derivative directly to the problem. The problem can be asked as applying first principle of difference. Now, your next problem is you have to find fx. Here, the problem is fx is equal to 8x cubed, 8, 8x squared plus 1. 8 x squared plus 1. 8 x squared plus 1 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 So we have this formula f dash x is equal to limit delta x tends to 0 fx plus delta x minus fx upon delta. This is your basic. What we will do, f dash x is equal to limit delta x tends to 0, change x by delta x. It will become 8 into x plus delta x plus 1 minus fx. Fx is 8x squared plus 1. Straight away open this. That is a plus b whole square, a square plus b square plus 2ab. So here it will be 8 into x square plus 4, 2ab. Okay. That will be 2x delta x, okay, plus delta x square plus 1 minus 8x square minus 1 upon delta x. So this plus 1 and minus 1 will be gone. Straight away do one thing, open this bracket and situate what it is left. This square will be removed. You will be left with 16x delta x plus 8 delta x square upon delta x. Take delta x common and you will be taking delta x common. So you will be left with 16x plus delta x. That means answer will be 16. This is again another method for finding the tangent of the slope. Okay.
Yes, sir.
Now comes the standard result and standard formulas and their application. Derivative of a constant is 0. You can see that fx is equal to 5, f dash x is equal to 0. Derivative of constant is 0. If you have any function in the form of x raised to the power n, it will be equal to n into x raised to the power n minus 1. Suppose we have to find the derivative of x is equal to 100. It will be 100 into your problem was x raised to the power 100. It will be 100 into x raised to the power 100 minus 1. That is 100 x raised to the power 99. If it is in the form of limit fx is equal to 3x to power 8. So straight away multiply 3 with 8 and reduce the power of x. So it will be 24x raised to the power 7. Now you have to apply derivatives of the function, those who are in the form of addition and subtraction, that doesn't make any difference. Fx is equal to 7 plus x raised to the power 12. The derivative of a constant number is 0 and your second function, second element is in the form of x raised to the power n. So that is the derivative of x raised to the power n is n x raised to the power n minus 1. So what we will be doing? We will be just bringing this 12 in front of this x and we will be reducing 1x. It will become 12x raised to the power 11. Now, cube root. Your function is dx is equal to cube root of x. Cube root of x can be written as x raised to the power 1 by 3. Now you have to differentiate x raised to the power 1 by 3. So it will become 1 by 3 x reduce the power of n. 1 by 3 minus 1. It will be 1 by 3 into x raised to the power minus 2 by 3. We normally don't keep the value, negative value in the numerator. So we will bring it down in the denominator. It will become 1 by 3 x raised to the power 2 by 3. There is another method of writing it. It can be written as 1 by 3 cube root of under root x square. Now see how this has been evaluated. Here what is happening? Another problem is y is equal to 1 upon x square. It is in the form of 1 upon x square. What I will be doing? I will be taking this to numerator. As I am taking it to the numerator, its power will change. It will become minus. Now I will be differentiating x raised to the power minus 2. Same numerator, this power will come in front of it, and now I will be reducing one power. So it will be minus 2 into x raised to the power minus 2 minus 1, which will be minus 2 into x raised to the power minus 3. We don't keep the power in negative to bring it down. It will become minus 2 by x cube. Third problem. Fx, your hx is equal to fifth root of x square. Fifth root of x square means 2 by 5. X raised to the power 2 by 5. We will be differentiating. We will be taking x to the x by 2 by 5 in front, and we will be reducing one power of 2 by 5. So that will become 2 by 5 into x raised to the power minus 3 by 5. It is in the form of minus 3 by 5. We will bring it down. That will become 3 by 5, 5 into x raised to the power 3 by 5, which can be written as fifth power of x. You can see how the problem was given to us, how it has been solved, and again the answer has been converted into the form in which the problem was. Is that clear? Three problems are there.
Yes,
Three,
it's clear.
nature is different, but method
The concept is same.
has been the same, and the answer has been converted into the same form in which the question was asked.
Yes, thank you, sir.
Another one. Y is equal to 2 by x. Take 2 common, because the 2 is a constant. Remove it. Now you are left with 1 by x. Convert this x raised to the power minus 1. Now apply derivative of x raised to the power minus 1 will be minus 1 upon x square. So your answer will be minus 2 upon x square. Your second problem here is ft equal to 4t cubed by 5 plus 3t square. Okay, fine, we can write it. F dash t is equal to 4 by 5 can be taken out, and we have to differentiate t cube. Differentiation of t cube will be 3t square, and differentiation of t square will be 2t. Here, derivative of t square is 2t, and derivative of t cube is 3t square. Simply multiply it and add it up. Here you can see that y is equal to 2 under root x. So under root of x means 1 by 2. X raised to the power, it is in the form of x raised to the power n. So that is what we do. We bring this power in front and reduce the power by 1. So here in this case it will be 1 upon x raised to the power 1 by 2, which can be written as 1 by under root x. We don't keep under root x in the denominator. That means we will be multiplying numerator and denominator by the same number. That means in numerator it will become under root x, and the denominator it will become x. Okay?
Yes, sir.
The thing is that you have to see to it how this has been done. I'm applying the same formula, that is x raised to the power n, in all these problems where we have algebraic terms, irrespective of their power, irrespective of their coefficients. The formula applied is derivative of x raised to the power n is n x raised to the power n minus 1. Everywhere the same method has been used. Now comes one of the most important part, that is the product rule. Product rule means two things will be given to you in product apart from the number. That means you have to identify these two things. We have denoted these two functions by u and v. See to it how the problem is given to you in the yellow box. There are two functions u and v, they have to be differentiated. When they are being differentiated, what is the procedure? See to it, keep the first function as it is. Differentiate the second one. Plus, keep the second term as it is. Differentiate the first one. See it very carefully what is being done. These are the two functions u and v. They have to be differentiated. When they have to be differentiated, so u will be kept as it is. We will be differentiating dv by dx plus second term as it is, differentiate the first term. First term is du by dx. Now we see to this. These are the two functions in product form. Derivative has to be calculated. Your fx is x cube plus 2x plus 5 into 3x power 7 minus 8x squared plus 1. What does this method says? What does this method says? These two brackets are in product. So take this as u and take this as v. I will keep the first bracket as it is, and I will be differentiating this. Its derivative will be 7 into 3, 21 into x raised to the power 6 minus 16 x raised to the power 1. And the derivative of constant is 0.
0.
This is what I have left. Plus this plus sign over here. Keep the second derivative, second function as it is, and differentiate this one. When I will be differentiating this, so this will become 3x squared plus 2x plus 0. Here it is. Now multiply the brackets, because it has to be brought to a composite function. After multiplying these brackets and simplifying, adding and subtracting like terms, you will get derivative of x as this one.
Yes, sir.
Now see. Now you explain me what has been done over here. We are talking about product rule. The function is now in terms of t. There are two functions under root t into b plus a plus bt.
We first keep the first one. For example, we denoted that the root of t is equal to u and a plus bt equal to v. Okay?
Okay, correct, correct, correct.
Uh, the derivatives
Go
will
ahead.
become like this. The root of t, the derivative of a
A
plus
plus
bt plus,
plus a
yes,
plus bt
a
into
plus b
derivative of
derivative of root of t. Again, we apply the same method we have learned in the previous slide. Okay,
now what is happening? Derivative of a is 0,
is
derivative
it
of bt will be only b.
only b because the power of t is 1. 1 minus minus 1 equal to 0. Anything in the day equal to the power is 0 equal to 1, and it become only b.
B. Absolutely correct. Now, here in this under root t, it is t power 1 by 2.
1 by 2
1,
manfi minus 1
1.
if we get
So you
the
can
driver.
see,
Okay.
yeah, yeah, here it is. 1
After
by
the
2,
manipulation, we get 1 by 2 t and the power of minus 1 by 2.
exactly. Now this has been brought down.
So,
This is your numerator and this has been brought down. Take up the
and
LCM,
the
you will get
final
2 root.
after,
Multiply it, this will become 2bt because 2
yes,
into b is 2b and under root t into under root t is t. So it will become 2bt. 2bt plus this bt will become 3bt and a will remain at the end. That means your answer will be a plus 3bt upon 2 under root t.
yes, sir. Good.
Correct?
Yeah, yeah.
When we are doing derivative or when we are finding derivative of two functions, we apply product rule and the product rule says first function as it is, derivative of second function plus second function as it is into derivative of the first
First
function.
function.
Here you can see. Now comes the logarithmic function. Your first function is x square and your second function is log 3x plus 7.
Yes, sir.
Okay. So what I will be doing, I will be keeping x square as the first function, x square into derivative of log 3x plus 7 plus log 3x plus 7 into derivative of first function. Correct?
Yes, sir.
Derivative of log x is the derivative of log x is 1 by x. Now I will be telling you chain rule. This is see to this line. I'm talking about this line now.
Okay.
This is dy by dx. Left hand side will remain as it is. This x square comes over here. We are talking about derivative of log 3x plus 7. So derivative of log x is log by x, 1 by x into
Yes.
derivative of x. Now see to it. What does that mean? This derivative log 3x plus 7 means 1 by 3x plus 7 into
3.
derivative of 3x plus 7. This is what chain rule is. You have to differentiate log x. You have to differentiate x till you get it power 1. I'm just repeating.
1 by x by derivative of x.
Yeah. So that is in case of log x. This is log 3x plus 7. What will happen? It will become
Log
1 upon
x.
3x plus 7 into derivative of 3x plus 7. Derivative of 3x plus 7 is 3 only. Moving further, this will be written as it is. Derivative of x square will be 2x.
Yes, sir.
Now simplify it. 3 into x square is 3x square upon 3x plus 7. Okay. Plus
Yes.
2x. Bring this forward. 2x log 3x plus 7.
Yes, sir.
I will be telling this today, and with this, I will be stopping. And I will request every one of you to start reading ahead of this. I will be telling you the quotient rule, one of a somewhat difficult part. Quotient rule, anything which is in the form of u by v. You can see in yellow box. Derivative of anything which is in the form of u by v. I'm just telling you what how it has to be done. Keep an eye on the yellow box only. If you have to square the numerator denominator, see to it. Whatever the denominator is, that denominator has to be squared. Okay? Now straight up a line.
Okay.
Come to the numerator. Come to the numerator part. Straight away write that v and
D-
differentiate the numerator. Differentiate the numerator minus the numerator into derivative of denominator. You can see over here, this is u by v square, whatever you is there, come bring it over here, and whatever was there, differentiate it. V into du by dx minus numerator into derivative of denominator. These all four things will be in the numerator.
Okay, sir.
Keep an eye on the yellow box.
Is the basic
Now, if we take up
structure of how to drive the derivative of
quotient
u by
u by
v.
v
Yeah.
from problem.
No.
Now, here the problem is this is y is equal to x cube minus x square plus 1 upon x square plus 1.
First we
The
square the x
numerator
square
is u,
plus 1.
right? Numerator is u and denominator is v. Straight
Yeah.
away, what I will be writing dy by dx equal to a big line upon square of this.
We will square the denominator v
Yeah,
x square plus 1.
whole square. Now bring this denominator in the numerator form.
Yes.
Here the denominator will come derivative of what the numerator is.
Yes.
Here it is. Minus sign the numerator into derivative of denominator.
Yes, sir.
Okay.
Okay.
Now differentiate it. X cube derivative will be 3x square. Derivative of x square will be 2x. And derivative of constant will be 0.
Zero.
And similarly, over here,
X square is 2x.
2x and constant
Is
of
0.
derivative of constant is 0.
Zero.
Now open it up.
And we remove x square plus 1 from the numerator and one of them from.
No, no, no. I didn't said that thing. I
Mhm.
simply said this is normal mistake what is being performed. So that is why please don't do it. Simplify numerator.
Multiplying the.
You don't remove this by this. Don't do that. Just simplify it. That means open this numerator and you will get this form.
Yes, sir.
This is the normal problem what learners do. They just remove this by this.
No, we cannot remove right now because it's not the factor of all the
Yes.
element on the numerator.
And exactly, very good. Exactly this is. You have to open it up, multiply it, add and subtract it, and just simplify it.
Okay.
Okay,
Yes, thank you.
so I will be stopping over here. This
Thank
is,
you so much.
in the meantime, you start reading ahead of it.
Okay, sir. Okay, sir. Very well trying.
Yeah, yeah, you try. No, I will be. I won't be skipping anything.
Hmm.
Uh, just go through the content so that it will be easier for you to understand it, and simultaneously, if you have any problem, any query, that can be answered thereaway only.
Okay, sir.
Okay?
Okay, okay. Thank you.
Any other questions from our participants? I'm concluding this session. Okay?
Okay. Thank you, sir. Good afternoon.
Good afternoon.